today's job is to plot a phylogeny. It shouldn't be too difficult. This plotting a similar one to one I've done already, so it's just a matter of getting the parameters the same and getting a new file ready, which is equivalent to one used previously. So this is kind of what I'll be plotting, this tree here. So I need to plot the phylogeny and this comparative data plotted at the terminals. So this is one type of data which is rather variable, and the one I plot today is a bit more conserved, so it should look a bit different, somewhat different, and that's what we're trying to depict through this plot. But the tree will be the same, it's just the comparative data at the terminals, these coloured bars, these will be different, and labels will be the same. So I found these are the set of commands I use for plotting this. So we have this Perl script does a bunch of different things. One of the things it does is print a bunch of R commands for. It will interpret an input phylogeny and print the R commands to plot this tree. So I need to run this on the same tree, but on a different comparative data. But a lot of these parameters, so these are, I've made notes of all the parameters I use here. These should be all the same. But we need to produce a new file to have this second type of comparative data in there. Okay, so let's get cracking with this. So we have these are all the parameters I need to set. So these are all usually a bit different when I plot various trees, but we're plotting the same tree, so we need to duplicate this. We need to create the. I'm going to rearrange this a bit. We need to create the file for the point colors at the terminals. And we run the Perl script, and we add a few commands to the set of R commands, which will plot some points indicating the comparative data, features of the comparative data. Okay, so first thing is to take a look at this. So we need to make, this is the main difference between these plots. So let's have a look at this, what this looks like. So we have a bunch of species and the state, A, B, C, or D. And so this is what we first need to find for our other characteristic, which we are plotting. So let's just search for so cover this one. Let's have a look at this. Looks like the same thing. So we've copied this to our working folder, and let's have a look at the file with cat. This looks like a pretty similar thing. So what we've plotted already, which we have here, is these. So these are states A, B, C, D. You can, well, the states aren't given, but they're just converted to colours. These are body length. So next what we want to plot is larval feeding guild. So P, this is, don't remember exactly, I think it's probably polyphagi, plant eater. Y, I forget what this, let's have a look. I forgot what codes I've used here. Okay, took me a while to find this. Okay, so here's the states. Unfortunately, the modelling method I used doesn't only accepts quite rather limited number of states, so I think I just used 5. But these are what these are here. So I should just make a note. So phytophagists and macrophagists are both as H, filter feeding L, aphid predator, or more general predator, caterpillar eating, also predator, saprophage S, and nest parasite or nest predator, both as Y. Okay, so these are the states. So let's go back to, where were we? Okay, so we know what states these are now. Let's change these to some color scheme. So we have H. Okay, so we've got this file here. We're going to change these different states. We're going to change these each to a specific color to indicate. So we can use sed, which will is Linux command, and it will search for some string and then change it to something else. So we have H, which will turn it into blue. L into red. P to green. S to yellow. So previously we had 4 states, now we have 5, so we'll just copy and create a new one. for Y, which are the harming predators or parasites. Colour, I don't know. Blue, red, green, yellow, say brown. And then we put that into a new file. We'll call that point colors larval feeding. And it hasn't worked. What we done wrong? Yep, we used the wrong file. Okay. This one. Okay, so in our plot, we're going to be searching for these terminals of the phylogeny and making a short coloured bar of these specified colours here. So that looks fine. Okay, so next we need to run this under these parameters. We don't need to copy again all this, but we are going to be using the same input tree. We'll put the okay, so we need to find this. So I don't recall if I've used this script on a different tree. If I did, then we'll need to set all these back to as were before. If I didn't, then these should all be the same, and we don't need to do. These all look the same, so probably not much we need to change. So this is the file we used last time. Let's have a look for this. Okay. Make a note. And then need our new file, which is point colors LF. This So I'm not sure why this one is different, but anyway, it needs to be 1. Okay, so we've specified to read this file, which is this one, which will, and the script will read all these, and well, let's have a look exactly what it does. So we read the highlight file, and this is an old format. This is really needed now, and it reads 2 columns. So this means start of line. This means the first column, tab separated, and second column. These are read into column 1, column 2. So we have the terminal in the column 1, and the entry, which will be the color, goes into and is stored into this hash here. This looks fine. Okay, so we'll just go ahead and try this. See what happens. So the terminals which are being coloured aren't the same, it's just different sets. This doesn't look right already. So it's 1361. So look at, where is it? It's not the screen output I was expecting. 1360. Okay, so for some reason I've been working on, so I've used this script for some other job. I don't remember what it is. We've got a verbose output. So anyway, let's try this again. Okay, so this is what it should look like. And this looks good already. So let's compare this to what we had previously. So as I say, these are 2 different traits. One of them rather labile, body length, and this one more conserved, as you can see. This is larval feeding mode. Yep, this looks good. This is what we wanting to show, that this is more conserved. Okay. So this will be plotted separately. This shows quartile distributions. So this one will be different. This won't be distributions. This will be just the counts of each state, and we needed just separate colours. but we have a note of these anyway. Okay, so I think this is job done already. Not too difficult. No problems. Yep. And this shows us well, of course, where all the gaps are. We may want to collect a bit more data. Particularly here, we've got close together two different states. Maybe we want to fill this out a bit. Not much. Yeah, so good. Job done. And okay, maybe quick summary of what we've done. So in this case, it is somewhat easier. We've already got a lot of this in place, so there's just a minor change required to plot this differently. But this is a benefit of writing down all your commands and implementing in this way. If you need to repeat something, it's always a lot easier to do so. So a lot of this was under the same settings. We just run a slightly different input file to make a different plot and depict what we want to depict. And okay, job done. Till next time.